Welcome to my presentation. In this presentation, let us look at some application problems related to factoring binomials. In this example, let us say we have a geometric figure of this type. Let me draw that. I have a figure which looks something like this. And then if I were to say this part here, if this is the point, and if I were to draw a line to this here, if I call this as 3a, and if I were to say from here to this edge, if this distance is 9a, and if this short distance here is 6a, we want to write an expression for the area of the shaded region. The shaded region we are looking at is this region here. The region we are looking at is this region. We want to find the area of this shaded region. This shaded region. And how do we do that? This is the way we want to do it. Step number 1. In this first step, I want to simplify this given problem. We have a rectangle, and the sides of the rectangle given to us are 6a and 9a. The long side is 9a and the short side is 6a. And from there we want to subtract a half of the circle. Let me draw a full circle, and then when I'm writing out the expression, I will write it accordingly. If I have a circle, and then if that is the center of the circle, and if I were to draw a line to the outside circumference of the circle, that is called the radius. So the radius is given to us as 3a. Okay, so what we need to do here is this. We want to write an expression now. We know I'll write this as step number 2. We know the area of a rectangle. The area of the rectangle is given to us as long side times the short side. Long side is 9a and the short side is 6a. And when I simplify this, 9 times 6 is 54, a to the power of 2, minus what I have here is a full circle, but what I want in this figure here is half a circle. So therefore the area of a circle is given to us as pi r squared. Pi times the radius to the power of 2. Pi, by the way, is a constant, and the mathematical constant of pi, the value of pi is 22/7. So the area is pi r squared. The area pi, we leave the pi as is. The radius is given to us as 3a, and then we go to raise it to the power of 2. When we simplify this, this is going to be pi times 3 squared times a squared, so that we can write as pi times 9a squared. Therefore we can write this one as 9 pi a squared, writing it all together. Since we have half of the circles to consider, this is a full circle a. Half of a will be what? 1/2 of 9 pi a squared, like that. So we have this part, this is the rectangle part, and this is the half a circle part. Okay, so we will now write those expressions together and see what we get. So the area of the shaded region is going to be equal to, I'm going to call this as step number 3. This we'll call it as step number 3. The area of shaded region is given as area of rectangle minus area of half a circle, right? And therefore that is going to be, area of a rectangle is 54 a squared minus area of half circle is 1/2 of 9 pi a squared, like that. Therefore, when I simplify this expression, I can write this as follows, isn't it? 54 is, I can write 54 as 9 times 6 is 54, and a squared is common, so I'll keep a squared there, minus 9 over 2 pi a squared. So therefore, what is common between these two? 9a squared is common. And what is left inside this set of parentheses? 6 is not accounted for, so I'll write 6. When I pull out 9a squared as common, 6 is left, minus. If I pull out 9a squared, what is left? Pi over 2 is left. So therefore, 9a squared times 6 minus pi over 2 is what is called, is the area of the shaded region. This 9a squared times 6 minus pi over 2 is the area of that shaded region for this figure here. So let me go back. This figure here. This is the figure we are looking at. This is the region. This region here. The area of that region is given by so the area of the shaded region is 9a squared times 6 minus pi over 2. This is the way we can apply the factoring of binomials to application problems of this nature. In my next presentation, we shall look at some more examples related to factoring binomials.